Hey, so let's look at the last thing we're going to do with logs. And last thing we're going to do with logs, we've already done all the operations. We used logs to solve exponential operations. So we're going to learn how to solve logarithmic equations. Okay, so let's get back to what a log is. As we said when we introduced it, log is, well, an exponent. If I look at log base 2 of 8, this again means 2 to the what? Your base is 2. 2 raised to what gives me 8. That would just be 3. So if I was going to write this out in exponential form, I would say 2 to the third power gives me 8. And that is true. I can check it like that. Here, this would say 3. Again, my base would be the base of my log, so log base 3 of 9. 3 to the what gives me 9. That would just be 2. And I can check. 3 raised to the second power gives me 9. So it is true. Log of 10, I know my base is just 10. When you don't see a base, it's 10. So 10 to the what gives me 10. And that would just be 1. And again, I can check. 10 to the 1 equals 10. So I can check that that is the right exponent. So here, where we had log base 2 of 8 equals 3, we're saying that 3 is the exponent, that the log equals 3. So, when I'm trying to solve a logarithmic equation, I can rewrite it into something called exponential form. So if I have log base 2 of x equals 3, I'm trying to figure out 2 raised to what power gives me x. But I don't know the x this time, so it's a little hard to figure out. But I know that my log of this equals 3, so my exponent is 3. So I can take my base, I can swing it over, and I can pop that up to make it an exponent. So I have 2 to 3 equals x, which means x just equals 8. And that's it. If I have log base 3, x minus 1 of x minus 1 equals 1, again I can do the same thing. Take my 3, pop it over, and get, because my log equals to 1, so that 1 is my exponent. So 3 to the 1 equals x minus 1. So x should equal 4. Add my 1 over. If I have something like this, log of x minus log of 5 equals 0, well, currently I got 2 logs. And so in order to do this, I'm going to have a single log. Well, we know how to write this as a single log. To write as a single log, I write the log in a fraction bar. Anything positive goes on top, so my x is going to go on top, and my 5 is going to go on bottom, and that's going to equal 0. Now I can try writing exponential form. My base is 10, so I can take my 10, swing it over, and pop up that 0. Get 10 to 0 equals x over 5. 10 to 0, well, anything to 0 is just 1, so x is just going to equal 1 times 5. Multiply my 5 over. And that's it. So that is, there's going to be 2 types of log equations. One of them is going to be logs and numbers, and that's how we can solve log and numbers. We can go back to the idea of what logs are, realize that the thing on the other side of the logarithm is the exponent. So that way I can swing my base over and actually pop that up into the exponent spot where it's supposed to be. Let's try one more. So log base 7 of x plus log base 7 of x plus 48 equals 2. I'm going to write this as a single log. So I'm going to get log base 7. I'm going to write a fraction bar, but this time both of them are going to be on top because they're both positive. So I don't actually need the fraction bar, so I kind of lied when I said I was going to write it. So that equals 2. Okay, so I'm going to take my 7, I'm going to swing it over and pop up that 2 into the exponent where it belongs. So I'm going to get 7 squared equals, and then this will be x squared plus 48x. Okay, so now it's a quadratic. 7 squared is 49. It's a quadratic, I'll get everything on one side equals 0, so x squared plus 48x minus 49 equals 0. So x plus 49, x minus 1 equals 0. So x is going to equal negative 49 and 1. Now you can't actually have a negative inside a logarithm. We're going to learn this when we start graphing logarithms, but there's another reason. Say, we're going to go up to the top right here. Say I have log base 2 of x equals, well, since we want to see that we can't have a negative, let's not make that an x. Let's make that a negative 5. Why not? Log base 2 of negative 5 equals something. Question mark. Again, that question mark would be the exponent, so I'm actually going to swing that over and make that 2 to the question mark equals negative 5. Now, is there any way for me to actually raise 2 to a power to get a negative 5? If I put a 0 in for my question mark, I would get 1. If I put a positive number, like a 1, 2, 3, or 4, I would get positive numbers, so 2 to positive would give me positive numbers. If I put in negative numbers, what do negative exponents do? They just flip it over the fraction bar, but they don't change the sign. Like 2 to the negative 1 would be 1/2. 2 to the negative 2 would be 1 over 2 squared. So I would still get positive numbers. There's no way for me to get a negative number inside logarithm. Okay, let's try another one. So let's see, I have log base 3 of x minus log base 3 of 2 equals log base 3 of 4. I'm going to start off the same way, right, as a single log. So I'm going to get log base 3. This time I'm going to have a fraction bar because I see I got a minus inside there. So my x is going to go on top, my 2 is going to go on the bottom. It's going to equal log base 3 of 4. So it looks a little different. This time I don't have a log and a number. Before I had log and a number, I took that base, swung it over, and made that exponent actually an exponent where it's supposed to be. This time I have a log base 3 equals a log base 3. Well, the log base 3 parts are the same. So it's kind of going back to where you had 2 to the x equals 2 to the 7, where your bases were the same. If my log base 3's are the same, that means I can basically just cancel them out. My insides have to be the same. That's the only way this is going to be true. Same way we canceled it out with bases and just let the x equal 7. So I'm going to have x over 2 equals 4. So x is going to equal 8. And that's it. Let's try another one. Say I have log of x plus 3 equals log of 18. Again, I'm going to get a single log. I don't need a fraction bar. I can tell that because I have no minus in front of my logs. So x times x plus 3 equals log of 18. Again, I have the exact same log on both sides. So I can just cancel them. Get x squared plus 3x equals 18. Quadratic, so I'll get everything over on one side equals 0. So x plus 6, x minus 3 equals 0. So x equals negative 6 and 3. And again, I can't have a negative, so my only answer is x equals 3. Okay, let's try another one. Log base 5 is 7 minus log base 5 of x plus log base 5 of 2 equals 3. I'm going to get a single log. Again, I see I got a minus, so I'm going to write a fraction bar, and it's log base 5, so I'll keep it log base 5. On top, I'll have the 7 and the 2. They're going to be multiplied, so I'll write a little parentheses there so I can tell. And over x. And that's going to equal 3. This time I have a log and a number. I know that number is the exponent, so I'm going to swing my base over and pop that number up to be an exponent. So I have 5 cubed. That's going to equal 14 over x. Continue solving. 14 is going to equal 5 cubed is 125, so 125 multiply both sides by x, 125x. And x is going to equal 14 over 125. And that's it. Ugly answer, but it's allowed to be. So the last one has natural logs. So I have natural log of 12 minus natural log of x equals natural log of x plus 1. I'm going to start the same way. Write a log and a fraction bar. Again, I got a minus, so I'm definitely going to write a fraction bar. 12 will be on top, x is on the bottom. And on the other side, I got natural log of x plus 1. So it really didn't matter we had natural logs. Again, I got the same log. Since I got the same log, I'm just going to cancel it. Get 12 over x equals x plus 1. I'll multiply both sides by x. So I'll get 12 equals x squared plus x. Quadratic, so I get everything over one side. X squared plus x minus 12 equals 0. So 0 equals x plus 4, x minus 3, and x equals negative 4 and 3. Again, can't be negative, so x just equals 3. Okay, so as we saw, there were two types. There was type 1 Type 1 had logs and numbers. So get single log, that's what we did in every single one, even if it was logs and numbers or the second type. Logs and logs. We always got single log. So single log on both. On log equals log, we got single log on each side. Turns out we only really need to ever get single log on one side, but single log on each side. Logs and numbers, we got single log on one side, single number on the other. So when it was logs and numbers, once we got a single log on one side and number on the other, that's when we went ahead and we popped that number, that 2, up into the exponent. It's called turning it into exponential form. So write as exponential. That drops your log. Logs and logs, once we got a single log on each side, something like this, they were the same log. So we could go ahead and just drop logs. So let's go back real quick. So stuff like number 1 was log base 2 of x equals 3. Log base 3 of x minus 1 equals 1. So all these ones that have logs and numbers, we're going to have to get a single log on one side, single number on the other side, and then write an exponential. The ones that are all logs, like the log base 3 of x minus log base 3 of x, log base 3 of 2 equals log base 3 of 4, we have to get a single log on each side, and then we can go ahead and just drop the logs. So there's 2 types. Hopefully you can recognize them.